In previous videos, I talked about adding, subtracting, and multiplying rational expressions. This time we're talking about solving rational equations. When you see the word equations, look for an equal sign because that tells you your answer is going to be in the form of variable equals something. We have fractions for the most part in this problem. The first term does not. So if you wanted to, you can make a fraction by just placing it over 1. And that's helpful for not only a number, but also if you have a variable so that you can clearly see what's missing in the denominator. Our goal is to get a common denominator first and then to get rid of the fractions altogether. So if I look at the first fraction that I just created, I'm missing 2n. This is the common denominator between all the factors because the last fraction has an n, but it doesn't have a 2. So what I'm going to do is I'm going to, as you see, put a parentheses around the entire problem, and I'm going to multiply every one of those fractions by the common denominator. So the way that this is going to work is I'm going to take each fraction at a time, so 2 over 1, and I'm going to multiply it times what's on the outside, the common denominator, which is 2n. If it helps you to see it as a fraction, again, place it over 1. So now what I do when you're multiplying fractions is just multiply the numerator as well as the denominator. So 2 times 2n is 4n. 4n divided by 1 is simply 4n. So I'm going to just write 4n minus, and now I'm going to take the next fraction and do the same thing. 1 over 2n. Everything is going to be multiplied times this 2n, which is the greatest common denominator, divided by 1. Now, what you learned in the last video is that if you have items that are diagonally or on top of each other that looks exactly the same, you can get rid of them. So that's what we're going to do. 2n and 2n go away, and they both become 1. And now I can do my multiplication of fractions. 1 times 1 is 1. And then at the bottom, 1 times 1 is still 1. So this just becomes 1 equals, and now let's do the very last fraction. 1 over n, again, is times that 2n over 1. And diagonally, I see that I have an n in common, so I can get rid of the n at the denominator of the first fraction and the n in the numerator of the second fraction. Multiplying across, 1 times 2 is 2. 2 over 1 is simply 2. This is the point where I can start, I don't have a fraction anymore, so I can just start solving for the variable. Now, what I want to do is move the constant. I'm trying to get n by itself. So since I already have a -1, I want to add 1 to both sides because what you do to one side, you do to the other in order to balance your equation. So that leaves me with 4n is equal to 2 plus 1, which is 3. Now, in order to get n by itself, I have to do the inverse. 4 times n, the inverse is dividing. So I want to divide by what's stopping n from being by itself, which is 4. And when I solve, my final answer is going to be n is equal 3 over 4. Now, I do want to double check to make sure that is true. Now, we talked about this before, and I said last time it wasn't a big deal because we were simplifying expressions, but this time it is a big deal, and that's excluded values. So excluded values, if you recall, are those values that make your denominator equal 0. We don't want that. So if I go back to my original denominator, I see 2n and I see an n. If I set both of those equal to 0, n cannot equal 0. So for those who need to see it, if I take 2n and I set it equal to 0, when I divide both sides by 2, n becomes 0. That's what we cannot have. And then the other one is simply n is equal to 0. So we can't have that to be the case. Anything that's going to make my denominator equal 0, I cannot use. It's called an excluded value. Okay, so now for example 2, this time we have 4b squared for one of our denominators and then 2b squared for the other two. So I can use the same concept. I'm going to put the entire problem in a set of parentheses. And then I'm going to ask myself, well, what's missing in each of the denominators? I can look at this and tell that 4b squared should be the actual denominator. This one's missing a 2, and so is this one. So over to the side, I'm going to put 4b squared because that is the common denominator. And now, instead of just writing it to the side like I did a few minutes ago, I'm just going to do it just looking at it this way and rewriting it. So what I see is 4b and 4b squared. I'm sorry, 4b squared and 4b squared. I can cancel those out and I'm left with just 5 here. This is really, so now this one may need to see 4b squared divided by 2b squared. Well, I can get rid of the b squared, but I'm still left with that 2. That 2 goes on top, which means it has to multiply against what's already on the top of that fraction. So it's going to be plus 2 times b minus 4. All right. And again, I already got rid of the denominator. Okay. So equals, that's my whole goal. And if I'm going diagonally here, I don't know if you can see that diagonally, once I cross out 4b squared divided by 2b squared, I'm left with the 2, and the b squared goes away as well. So 2 times 1 is simply 2. My whole goal was to get rid of that denominator, but I had to first decide, well, what's the common denominator between all 3 fractions? At this point now, what I want to do is I want to make sure I simplify everything. So that means I'm going to have to distribute that middle term. So 5 plus 2b minus 8 is equal to 2. Now what I want to do is I want to combine my like terms on one side of the equation, and then I will move everything over until I can get b by itself. So I'm left with 5 minus 8, which is negative 3, plus 2b equals 2. And the first thing you want to do is move your constant. So that's what I'm going to do, plus 3. What I do to one side, I do to the other. And I'm always doing the inverse because I'm trying to make it 0. That's going to be 2b is equal to 5. And then now I want to solve for the variable b. So I'm going to divide both sides by what's stopping b from being by itself, which is 2. And my final answer is b is equal to 5 over 2. Again, I have to go back and make sure that that is true. What is my excluded value? X cannot equal. And now if I look at my denominators, I have 4b squared and 2b squared. So if I set those equal to 0, again, x cannot equal 0. That's my excluded value. And since 5 over 2 is not 0, I can use that number. All right, and then this is the last example that I'm going to do. It looks a little difficult, but what you want to do is you want to factor it first, or at least that's what I do. So let's go ahead and do that. And since this is n squared, I know I'm going to have 2 sets of parentheses, n times n. And now I'm looking for 2 numbers that will multiply to give me that negative 10, but will add to give me the 3. So that's going to be a positive 5 and a negative 2. 5 minus 2 is 3. 5 times negative 2 is negative 10. Take that information, and that's what's going inside of my binomials. On the bottom, I can factor out the greatest common factor, which is 2. I'm left with n squared plus 12n plus 72 divided by 2, which is 36. I can further factor that, and I will do that in the next step because it's getting a little messy here. So let me go back to green here. The first one we changed to n plus 5 times n minus 2. This next one, the denominator is 2 times, and again, I have n squared, so I'm going to do 2 sets of binomials, n times n. This time I have 36. 36, what 2 numbers can I use to multiply that give me 36, but add to give me 12? Well, that's pretty easy. That's going to be 6 and 6, and watch your signs. They're both positive. Now my next fraction was 1/2. And then it's set equal to the fraction 2 over, well, n squared plus 12n plus 36 is what I just actually factored. So that's still n plus 6 times the quantity of another n plus 6. Okay. So now what I want to do is do what I was showing you a few minutes ago. And I'm going to put the entire problem in a big parentheses, and I'm going to multiply it by the greatest common denominator, which is 2. So that is going to be 2 times, the first one is the greatest common denominator, I'm sorry. So if I look at the second fraction, it's missing that quantity of n plus 6 times another quantity of n plus 6. If I look at the third fraction, it's missing the 2. So I need 2 times n plus 6 times another n plus 6. I'm going to take each fraction and I'm going to try to get rid of that denominator by using what's on the outside of this parentheses. So I'm multiplying it. When I do that for the first fraction, my first fraction, the entire denominator disappears and I'm only left with n plus 5 times n minus 2 plus, now when I look at the second fraction, the denominator, only the 2 disappears. So I'm still left with that n plus 6 times another n plus 6. When I look at my third denominator for the third fraction, the n plus 6 times n plus 6 goes away, but I'm still left with the 2. So that 2 has to be multiplied by the 2 that's already in that fraction's numerator, which is 4. Now I've gotten rid of all of my fractions and I'm going to distribute. When I distribute, I am using what you guys probably call FOIL, what is distributive property. And some of these I already have the answer to because we already had the answer. We just put it in fraction form. So let's go back to what we were doing here. That first one is going to be n squared minus 2n plus 5n minus 10. And that's just me following the arrows, n times n times -2, 5 times n, 5 times -2. And then over here, this is going to be n squared plus, I'm just going to, well, 6n plus 6n plus 36 equals 4. Now I want to combine like terms. I have an n squared and an n squared. I have those 5 n's, those n's, and I have the constant over here, the constant over here. So I end up with 2n squared. I'm just gonna, let's see, 5 minus 2 is 3. 3 plus 12 is 15n. And if you need to, just start crossing them out so you don't get confused. And then -10 plus 36 or 36 minus 10 is positive 26. It's all equal to 4. Well, we want this 4 to become a 0. So we're going to do the inverse, which is instead of a plus 4, minus 4. And we're going to combine it with that constant. In doing so, I end up with my 0 on the other side of the equal sign. Do not get rid of that equal sign. Some of you want to do that. So I have, bring down everything else, 2n squared plus 15n plus 22. And now if I look at this, I will try to factor out the greatest common factor. I don't see that I have one, so I'm just going to try to factor. So I use the box method in doing that. My first box is my first term, which is 2n squared. My last box is my last term, which is positive 22. I am trying to find two numbers that will replace 15n. Where I'm getting that from is 2 times 22, which is 44. And I'm trying to find two factors of 44 that will add to give me that 15. So that's positive 11 and positive 4. So I'm going to take that information and that's what's going to go in the box here. So it doesn't matter which goes where. Plus 11n. And I always put the variable with it because again, it's replacing that 15n. So 4n plus 11n replaces the 15n. Now what I'm going to do is factor to the left the greatest common factor. I can factor out a 2n here, and I can factor out a plus 11. The sign that's nearest where I'm writing is the sign that comes out. So I do the same thing going up. The greatest common factor is n, and then again, this sign is plus, so that's what's going to come out. And then between the 4 and 22, I can take out a 2. If I want to make sure that's correct, then all I have to do is just multiply each row times each column, and that should be the answer. And you just do that for the bottom row as well. So those are my factors. Once I get those factors, I can write them over here, 2n plus 11 times n plus 2. And again, don't forget equals 0, because you have to set each one of these equal to 0 to solve. That's what solve means. We're trying to see what can I put in the place of that variable to make it equal 0. So 2n plus 11 equals 0, and n plus 2 equals 0. When I solve, I am going to take the constant and I'm going to do the inverse, which is in this case subtracting 11 from both sides. I have 2n is equal to negative 11. And then I want to divide both sides by what's stopping that variable from being by itself. So n is equal to negative 11 over 2 in this instance. And over here, if I take the inverse of positive 2 is negative 2, what I do to one side, I do to the other. N is equal to negative 2. So those are my two answers that I have when I am solving for this particular rational equation. I have to go back, look at my original denominator, and see, and it's better to see it in factor form, because you can see that if you're looking at this factor form here, that n cannot be negative 6. That's the only thing that it cannot be, because n plus 6 set equal to 0 would be negative 6. So if I look at my answers again, neither of those are negative 6, so I'm fine.